Hello there. We have a little podcast this evening. It should probably take anywhere from 12 to 15 minutes. Make sure that you get this done. Pay attention to what's going on. Pause things if you need to. Go back and review. And please write your questions in the margins of your Cornell notes. So the topic is conversion factors, and this is part of our Understanding and Communicating Scientific Measurements unit. You'll notice here on the upper left-hand corner, we have a weight conversion chart, and this is up here mainly so that you can refer back to the kilogram and pound equality. So 1 kilogram is 2.2 pounds, but it also talks about other English metric, and English equivalencies. Okay, so let's get started here. What are our objectives? Two objectives. First, to understand what a conversion factor is and to be able to put one together. And then once we're able to put those together, how do we incorporate those conversion factors into a simple problem in order to convert from one metric unit to another? And we are starting out very simply. We will work on converting derived units later. A derived unit is just something like miles per hour or grams per cubic centimeter, where you have actually 2 units or more put together. But we're just going to be converting one unit to another unit. So what are you going to need? You're going to need your Cornell notes, a pencil, and your calculator. So go ahead and pause, go get those things, and run back. So what are conversion factors? Well, I have 3 things here that we're going to look at. Fairly simple too. The first thing that I always like to say in terms of a conversion factor is that it's a fraction that is equal to 1. A fraction that is equal to 1. Now, I think if you think about math class and you think about fractions equal to 1, what you think about is the same number on the top and the bottom of a fraction bar. So the numerator and the denominator would be the same thing. So this would sort of say here that if you have 4 over 4, but of course that's going to equal 1. You know that anything on top of itself is going to equal 1. In science, though, conversion factors are a little bit more difficult than this, but not much. In science, conversion factors always include both a number and a unit in the numerator and the denominator. So if you look up here, we have a 4 in the numerator, we have a 4 in the denominator, but there are no units. So what that means is this. Let's say I want to create an equality. So in order for me to do that, I have to have 2 different units. So let's just say I have meters and I have centimeters. What I would do then is I want to make sure I have the same value on the top as I do on the bottom. So I'm going to look at my larger unit, and I'm going to put a 1 next to it, and I'm going to figure out in my head how many centimeters are in a meter, and there are exactly 100 centimeters in a meter. So now we have a numerator that's equal to a denominator, but it's not just numbers, it's numbers and units. So 1 meter over 100 centimeters is actually equal to 1. So why do we care about this? What's the big deal? Well, what this allows us to do, and we can construct a conversion factor, is it allows us to be able to take one unit and convert it to another unit by taking our given and then multiplying out. Okay, so let's move on. How do we use these conversion factors? Make sure you're recording all these things in your Cornell notes as we go. So to convert a quantity from a given unit to an unknown unit, we would do this. Here's a question. How many cubic centimeters are in 6.67 liters of water? Okay, so cubic centimeter is abbreviated cm with a little cubey-doo on top, and we want to know how many of these. So I'm just going to put a question mark above those. Okay, so 6.67 liters of water is our known. So when we're constructing a very simple conversion factor, the first thing we think of is, What do I know? Well, I underlined what we know. We know that 6.67 liters of water are present, all right? So what we want to do, and I'll work down here, is we want to take the unit that we know, and we want to put it underneath the fraction bar. And just go with me on this, because it's important that as we string more and more conversion factors together, that we try to work from bottom to top. And sometimes it's top to bottom, but we're going to do bottom to top for now. Okay, and what are we converting to? That's the second part. We have to figure out what unit are we going to. And if you look up, I put question mark cubic centimeters at the top. So the unit that we're going to be converting to is a cubic centimeter. So if you look at this for a second, the unit that we know is on the bottom. The unit we want to convert to is on the top. So it's kind of backwards. We're used to working from top to bottom, but you'll find that this is helpful. So then the last thing we do is we figure out what numbers have to go in front of these units in order to make the numerator equivalent to the denominator. So I look for the bigger unit, it's liters. I put a 1 by it, and I figure out how many cubic centimeters are in a liter. And you should know that there are 1,000 cubic centimeters in 1 liter from having built your metric cube. And so yes, this does equal 1. So this conversion factor right here is going to allow me to take the 6.67 liters of water and multiply it by this conversion factor here. And it's going to allow me to get an answer in cubic centimeters. So that's what it's going to look like. Hopefully a little bit neater on your paper. All right, so let's take a look. I'll do the first couple of these with you, and then what I'd like you to do is to figure out the rest of these conversion factors and write them in your Cornell notes. If you need to pause, that's great. Go ahead and do it. All right, so we have centimeters to meters. So we want to go from cm, centimeters, which is a smaller unit, to meters, which is a larger unit. So what we do is we look at this and we say, okay, if we have centimeters, that's going to be our given. So we would put centimeters on the bottom, and we're going to meters. So what you don't know goes on top. Then what you have to do is look at the larger unit, which is meters. You stick a 1 by it, and then a 100 on the bottom. The reason I say to stick a 1 in front of the larger unit is because sometimes what you could do is you could put 1 centimeter down here. Well, that's your smaller unit. So then what you'd end up having to do up here is put 0.01 meters, and you start using these fractions that are decimals actually, and it gets a little bit confusing and it's not as consistent as we'd like it to be. So put your 1 by the larger unit. Okay, here's another one. I know liters and I want to go to cubic centimeters. So what do I know? I know liters. I stick at the unit on the bottom, and I want to find out cubic centimeters. So I stick that unit on top. A 1 and a 1,000 make this fraction equal to 1. The top value is equal to the bottom value. This allows us to convert liters to cubic centimeters. Okay, the third one, grams to kilograms. Once again, if I know grams, it goes in the bottom. If I'm converting 2 kilograms, it goes in the top. Kilograms is bigger. I stick a 1 by it, and then I know that there are 1,000 grams in 1 kilogram. And these metric equivalencies should be fairly basic for you. If you can't remember them, go back and look at your notes. King Henry died by drinking chocolate milk, and figure it out. Okay, so these last couple I'd like you to do on your own. Miles to kilometers, and this is a value that's going to help, or an inequality that's going to help you put your conversion factor together. So if you run a 5K race, that's 3.1 miles. In kilograms to pounds, 1 pound is equivalent to 2.2 kilograms. So go ahead and do those, pause, and we'll go over those in class. So let's have a couple examples here of how to use these conversion factors so you can get a good look at it, okay? So here's me, and I'm on Long Lake in Wisconsin where my husband lives, and didn't feel much like skiing that day. kind of tired, so I took out a sail and I was going back and forth across the lake here. And this is called ski sailing, which is a lot of fun. But when I ski my half marathons, I don't get to use a sail. I have to use my arms and I have to work at it. So each year I do a half marathon Nordic ski race, and it's 24.3 kilometers long. So what I'm wondering is, how many miles am I skiing? How many miles am I skiing? So we know how to put the conversion factor together. Let's add one more step. If we want to truly convert this, what we're going to have to do is we're going to have to start by writing our given down. And our given is 24.3, whoops, not kilograms, kilometers. Okay, 24.3 kilometers. Now, remember what I told you. The unit that we know goes on the bottom of our conversion factor, and the unit that we want to find goes on the top of our conversion factor. So just put that in there to start with. Now I'd like you to notice what I did. I started with my given, I wrote a time sign, I wrote a fraction bar, I have kilometers on the bottom, I have miles on the top. What you'll see is if I multiply this value times this value and I divide it by this value, that my kilometer value is going to cancel and I'm left with miles. This is exactly what I want. Now I have to look at this and I have to determine what I'm going to use to make this a conversion factor so that the numerator and the denominator are equal. All right, so I happen to know a 5K race is 3.1 miles. And if you have any friends that run cross country, or if you run, this is the typical high school distance. All right, so if you look at this then, what we do is we're going to be multiplying 24.3 times 3.1, and then we're going to divide that by 5. So I got my phone out here, 24.3 times 3.1 divided by 5. And it says 15.06. I'm going to use 3 significant figures, and I'm going to answer this as 15.1 miles. So my ski race is 15.1 miles. All right, so my typical training day could be 20 miles or more. All righty, so hopefully that starts to give you an idea. Let's look at another one. Okay, here are my greyhounds. There's Tazo, there's Roxy. She's the mama dog, he's the baby dog, and as you can tell, he's very spoiled. Well, Tazo weighs about 67.5 pounds. Yeah, I'm recording right now. So if Tazo weighs 67.5 pounds, how many kilograms is this? Well, we've got 67.5 pounds. That's our given. All right, we write that down first. We put a time sign and a fraction bar. I know pounds. I want to get rid of pounds. I put that on the bottom. I put kilograms on the top. As we said before, they're 2.2 2.2 pounds and 1 kilogram. Now, if you look at the pounds, you can see we have pounds as a numerator, pounds as a denominator. So if we multiply 67.5 pounds by 1 kilogram and divide by 2.2 pounds, pounds will cancel. The math here involves simply multiplying 67.5 times 1 and dividing by 2.2. All right, now you really don't have to multiply by that 1, but if there's another number there, I'm just saying that you would have to take that into consideration. So 67.5 times 1 divided by 2.2. And that's going to give us an answer of 30.68, blah, 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 lots of numbers. And we're going to just call that 30.7 kilograms. So Tazo weighs 30.7 kilograms. Okay. Slide 9. What you're going to do right now is pause this, and you're going to write down just 4 conversion factors, that's all. So pause this, read through, and show me 4 conversion factors: inches to yards, grams to milligrams, miles to kilometers, and hours to minutes. Put this in your Cornell notes, please. Okay, when converting a derived unit, it becomes a little bit more tricky. So record this problem in your notes, and we will solve it together in class. Here we are, marine iguanas, and there's a picture down here of some marine iguanas all lined up sunning themselves. Swim at a rate of 30 meters per minute. What is their speed in kilometers per hour? So go ahead and pause this, write that down. Don't solve it yet. Let's do it together in class. So when this assignment